Is the recording. Welcome everyone to this webinar on reducing CO2 emissions and operational costs through energy efficiency programs related to heavy duty vehicle fleets. This is a webinar that is hosted by the UN Environment Programme and GIZ with the support of a number of organizations that you can then see on the screen there. Next slide, please. Just to give you a bit of background around this webinar. This is the third of three webinars in a series on energy efficiency programs. The first webinar was hosted on light duty vehicles during the Transport and Climate Week, the second on 2- and 3-wheelers, and now the third here on heavy duty vehicles. Felipe, are you able to move the slides? Just so you can keep up. There we go, with my errant rambling. For those who don't know me, I am Sean Cook. I am the lead of the freight portfolio at UN Environment Programme. And now you can see the agenda on your screen for the webinar for today. It's an hour and a half, and we have three very esteemed speakers with us today to share in a discussion around heavy duty vehicles and energy efficiency programs. I'm going to give a very brief welcome and introduction before handing over to my colleagues, but there will also be plenty time for questions, and you can put those into the chat or the Q&A option at the bottom. And if you have a particularly significant point that you would like to make verbally, please just raise your hand and we will try to allow you to do that as well. I think the setting of the scene is often very useful because, especially with those who may be coming to this webinar who are from the energy efficiency space or from one of the other transport modes and may not understand the context of heavy duty vehicles and the freight space. So a few statistics I like to put up front related to the work that we do in this space are things like heavy duty vehicles. So these are our trucks and buses, account for about 4% of the vehicles that are on the road. But those 4% of vehicles account for 35% of the CO2 emissions from on-road vehicles, and 73% or more of the nitrous oxides emissions from on-road vehicles, over 60% of air pollution through particulate matter. So you can see that through a very small number of vehicles, they're having a very outsized effect on both the climate change as well as the air pollution within the environment of some of the major heavy-duty vehicle routes. And so they've always had a fairly high significance, but there hasn't been as many options or solutions available that have been cost efficient. And energy efficiency programs are obviously one of them, but we're now starting to see a significant number of programs that are gaining traction within the space. And I think this is a very timely webinar to be able to take some stock of the progress that has been made, and especially by our three speakers who have made some substantial progress themselves. UNEP, as an organization, we've had a freight program for quite a while, as has GIZ, but we're now embarking on a fairly more ambitious approach with a number of partners, including those in the room today. This takes many forms, including pilot projects and in-country projects that we're doing in more than 60 countries, but also we're working on a global green road corridors initiative in order to make some of this progress in the HDV space more visible globally, as well as to start to direct a lot more investment into the infrastructure that can unlock this progress. So I think we'll move on now to the first of our three speakers who have generously agreed to share some of the insights, the wisdom, the knowledge that they've gained through some real on the ground successes. And the first of this is Samhita Shilida. She's a director at the Rocky Mountain Institute. She's been leading their carbon-free transportation initiative and their India programs, and has a wealth of experience across multiple transport modes within especially the electric transport space and across multiple continents. But she has a particular experience in the zero emission truck space that we're quite interested in. And there's really no one better to be sharing the experience on the work across financing, policy, infrastructure than her. And thank you so much, Samhita, for agreeing to speak with us today.
Thank you so much, Sean. Thank you for your kind introduction, and welcome everyone to the webinar. I'll share my screen quickly and we can get started. And I'm assuming you all can see my full screen. So hello everyone, I'm Samhita Shilidhar. I'm director with RMI's transportation program, and today I'll be presenting on transforming trucking whole system approach to zero emission truck deployment. For those who don't know about RMI, we are basically a global think tank working in the field of energy efficiency for different end-use sector. We are currently working and partnering in over 60 countries, and we are working on 4 major sectors: electricity, buildings, transportation, and industry. And today I'll be particularly talking about zero emission trucking. So the trucking sector plays a critical role in driving economic growth and enhancing GDP of nations by transporting goods throughout the supply chain, from raw material all the way to final consumption. As economies and population is expanding, the demand for goods is also expected to increase. Between 2021 and 2024, the freight demand from trucks grew by 9%, and it is further projected to increase by almost twofold in the next 2.5 decades. To satisfy this growing demand, the global trucking sale is also going to increase. And as you can see on the exhibit on the right, the truck sales are expected to increase by almost 40% by 2050 compared to current levels. And 8 different regions, Australia, Brazil, China, Europe, Japan, India, South Korea, and US, will make for about 60% of the total truck sales in 2050, while 40% will come from the rest of the world. Sean already prefaced this, but although trucks comprise just 4% of global on-road fleet, they contribute disproportionately to energy demand and have disproportionate impact on climate. Currently, trucks account for a quarter of total energy demand in the transportation sector, contribute to 27% of on-road greenhouse gas emissions, and also over 30% of the air pollution. Zero emission trucks offer a compelling alternative to the conventional IC engine trucks, and transitioning to them can reduce operating costs as well as emissions. First of all, zero emission trucks can completely eliminate NOx and tailpipe emissions and PM, and also substantially reduce carbon dioxide emissions based on the cleanliness of the grid. This can eventually improve the air quality and public health. Beyond the emission reduction benefits, zero emission trucks also present a compelling case for reduced operating and maintenance cost. Since they are mechanically simpler than IC engine vehicles, BETs and FCETs can totally reduce different kinds of operational costs as well as improve the energy independence by reducing reliance on fossil fuels. To achieve net zero emissions from trucking globally, though, almost all of the trucks sold by 2050 must be zero emission trucks. And this would enable close to 30 gigaton of cumulative carbon dioxide savings between now and 2050. ZETs are already gaining momentum all across the world, and this is mainly because of different government targets that are being set around. So the time for the transition to zero emission trucking movement is really now. Most of the targets around ZETs are observed in Europe, which is led by EU's target for reducing net transport CO2 emissions. However, other ZET markets such as South America, Asia have also started introducing targets as part of their medium and long-term strategy. By setting these kind of emissions, government is starting to send a strong signal to industry players to start investing and deploying in zero emission trucks. Between 2020 and 2023, the global ZET sales have already increased threefolds, with the current numbers hovering around 54,000. There is also a lot of early deployment seen across specific use cases that have high utilization and specific closed loop applications, which make them suitable for zero emission trucking deployment. So, some of the use cases which are really ideal for ZETs are port applications, which is a typical closed loop application, cement and other heavy industry, trucking corridors, and e-commerce. And you can see a lot of these zero emission truck pilots all across the world. One of the example is the corridor in China between Chengdu and Chongqing. In the United States, different companies such as PepsiCo and DHL are rolling out zero emission trucking pilots. In Europe, Mars has deployed 300 trucks. In Brazil, the Iberdrola Green Corridor has multitude of fast and slow chargers along the route. In India, companies like Adani, Tata are taking substantial efforts in terms of deploying zero emission trucks. And in Africa, there is a strategy around greening the Northern Corridor for freight deployment. Despite all of these benefits and growing momentum, there are still a lot of barriers that exist with respect to zero emission truck, considering how nascent the whole market is. In terms of policy, there is a growing number of Z policies, but it is still missing in most of the part of world, especially developing nations. The upfront cost of zero emission trucks is almost still as high as almost twice in most of the cases and in most of the geographies. And even though zero emission trucks typically have lower fuel and maintenance costs than diesel trucks, the upfront investment, which often includes expensing installation of specialized charging infrastructure, it adds to the initial financial burden, making initial costs much steeper for fleet operators. This also eventually leads to difficulties for trucking companies to secure affordable financing, as traditional lending models may not adequately account for new technologies with the long-term cost savings. While financing has been a challenge in many regions, it has especially been acute in developing countries where there is limited access to capital. Moreover, there is also a limited availability of suitable zero emission trucking models that meet the demand of the market. And almost 90% of the zero emission trucking models that are available right now are in United States, China, and Norway, which is making it really concentrated in these three geographies in terms of the supply side. And finally, there is lack of widespread charging or refueling infrastructure and robust grid that really needs to be there to meet the demand of zero emission trucks. Despite all of this, there is a whole system approach which is required in terms of spurring the zero emission trucking deployment. And through supportive policies, innovative financing, technology development, and widespread infrastructure, we can really unlock the key to Zs. To start with technology development, there are diverse arrays of different technologies that exist in the market right now with respect to Zs, and each of them is tailored to meet different kind of specific use cases. In the table here, you can see I've compared 8 different technologies and assessed their efficiency, payload, refueling, technology lock-in, and commercial maturity impact. For depot charging, which refers to battery electric trucks with fixed chargings at depot with low power chargers, they have relatively slower charging speed and are ideal for overnight, for trucks that are parked overnight or for extended periods of time. And route fast charging is really good for quick top-ups during the long-haul journeys. With swapping, battery electric trucks can swap the batteries at dedicated swapping station. For catenary and induction, these are in route charging methods where either through overhead wires or through underground coils, the trucks are charged. This is really good for fixed route applications. If we speak about hydrogen trucks, they rely on green hydrogen as a fuel through refueling stations to power the trucks. And two key options that are there are hydrogen fuel cells and hydrogen ICEs. And both of these options are really great because there is less payload impact and the refueling time is also very high. So it's really good for bulk commodities covering longer daily distances. All this being said, there is no one size fit all solution, and all of these technologies have to coexist. So it is really critical to assess the technology and its application. Moving next to supportive policies, there are the combination of different demand side, supply side, and infrastructure related policies is really the key when it comes to unlocking zero emission trucks. In the infographic here, I have highlighted some of the existing examples also that are already taking place in different parts of the world. For example, in California, there is a fleet purchase requirement which enables and mandates fleets to meet certain percentage of their fleet to be zero emission trucks. There are mass awareness programs such as Shunya campaign in India, which aims to increase awareness about zero emission vehicles. There are also different scrappage incentives which are promoting the use of ZETs over ICEs, and different fee-based and purchase subsidies which are intended to reduce the upfront cost. In terms of supply side, there are various fuel efficiency norms prominently in Europe and different parts of the world, which are pushing higher efficiency of trucks, but also with the stringent requirements, pushing OEMs to achieve zero emission trucking development as well. And then there are also different fiscal incentives that could eventually promote manufacturing. Um, California also has ZEV credit program, which mandates certain share of the sales for OEMs to be electric. And finally, on the infrastructure side, different kind of policies such as incentives or grants or land subsidies, leasing model for land, or optimized tariff for zero emission truck charging, and incentives for upstream infrastructure development can really unlock the key in terms of widespread infrastructure. Moving next to financing. As I already touched on this, the current kind of risk in the market right now is with respect to having financiers having low confidence with respect to financing zero emission trucks, and thereby being limited financing options. So a lot of these risks and a lot of this low confidence stems from different business models risks, such as lack of reliability on operation and performance, anxiety associated with utilization of sets, and different market risks such as lack of secondary market, lack of clear policy signals, and nascent and growing nature of a lot of zero emission trucking OEMs. Ultimately, this leads to higher interest rates, shorter loan tenures, and limited financing options. However, a combination of financing tools such as debt, equity, risk sharing, viability gap funding, government budgetary allocations can really unlock the commercial as well as private investment. In addition to that, different de-risking practices such as demand aggregation, reducing information asymmetry through data-enabled mobility, corridor development, and aftermarket support can de-risk the entire ecosystem, especially with respect to the expected loss. And finally, different innovative zero-emission trucking business models such as leasing and insurance um, can unlock more funding and allocate risks to more suitable market actors. And ultimately, all of these solutions can unlock funding in the whole ecosystem. Finally, in terms of the widespread infrastructure, I already touched on the demand aggregation piece, and one of the key elements when it comes to deploying charging infrastructure, particularly in different geographies, is definitely through zero emission trucking corridors. So, zero emission trucking corridors refer to a stretch of highway with requisite infrastructure, which can be a lever for catalyzing the entire market. This also provides a proof of concept by showcasing techno-economic visibility and operational performance of battery electric trucks or fuel cell electric trucks. That way, fleet aggregators can be confident that BETs can replace the diesel vehicles. Corridors are also an excellent way to aggregate demand and increase manufacturing so that it can also create confidence amongst OEMs to produce BETs at scale. It eventually lowers the cost by having dedicated zero emission trucking corridor, as it can facilitate higher infrastructure utilization and ultimately manage risk by focusing resources along one corridor, representing an opportunity to orchestrate public and private sector investment to drive the speed and scale of the entire market. But how exactly do we develop the corridors? This is one of the approaches that has been taking place in a lot of different geographies across all of the different continents, right from a lot of corridors in India, China, many in the US, many in consideration in South America, Africa, and Europe and beyond. So the first key is really to identify the right corridor based on truck traffic, presence of major industries, access to ports, and then engaging with the right set of stakeholders such as OEMs, infrastructure providers, to estimate the charging infrastructure and requisite grid upgrades that would be required in terms of developing adequate infrastructure on route, and then ultimately kickstarting the asset deployment. An important piece of this equation is also proactively making sure that the grid is ready. It is really important for policymakers to know when, where, and how much zero emission truck load is going to come in place so that they can prioritize siting charging infrastructure and also plan the grid accordingly. RMI has developed a grid up tool, and I have a quick screenshot of it without diving too much into detail, which kind of supports different utilities by forecasting when and where energy and power demand will materialize from vehicle electrification. This tool is uniquely detailed and flexible in terms of being able to assess the greater insight into zero emission trucks play. Um, Finally, I just want to kind of close the presentation by saying that all of these elements don't come together on their own, and they require trust, alignment, and shared vision across the sector. Um, and collaboration is really the key when it comes to unlocking different solutions. RMI has worked extensively in different geographies. We have been working in India on ports related trucks deployment, partnering with state governments in terms of zero emission trucking as well as EV policy support. We are working in China on different data and technology side of things, in the US on grid and infrastructure side, and currently also recently exploring more and more opportunities on early use cases in Southeast Asia and Africa. And based on all of this global insight, the as kind of a cliche as it might sound, collaboration is really the key when it comes to unlocking the greater benefits. By having collaboration between public sector players such as national and subnational governments, as well as private sector players such as manufacturers, infrastructure providers, we can unlock policies that help drive first mover, set adoption, mobilize finance, scale manufacturing, and develop requisite grid infrastructure. With that, I'll leave you all with that thought. And really, again, thank UN and GIZ in terms of giving this opportunity to share insights from the presentation, and really looking forward to meaningful discussion later.
Thanks so much, Samita. A lot of information there, and just showing a small window into all of the work that you've been doing over the last few years. Before we open up for questions, because I know that there's likely to be a few, we do want to add a slightly different perspective though as well to enrich this picture, and that's why I will now invite our second speaker in, Abdul, and then open up for questions to both of them. So Abdul has a background in industrial engineering and has spent a number of years, I won't say how many, but a good number at the coalface, if we're going to call it that, of sustainable trucking. He saw this before most and joined early. And he's been leading the decarbonization efforts at a trucking company in South Africa. But his deep experience in the sector and knowledge of the evolution of sustainable trucking over the last few years has also made him a prominent consultant in the development sector space, in the policy space, and somehow on top of all that also found time to write a book on road freight sustainability 4.0 is what it's called, and pretty much details a wealth of knowledge that has been gained from his work in this space. And he is now going to share just a snippet of that with us as well, from the perspective of the trucking operators themselves. So thank you so much for joining us, Abdul.
Thank you so much. Quite an introduction there. I hope I can live up to it. You're very kind, Sean. Much appreciated. Good morning, everyone. My name is Abdul Kamda, and for my sins, I'm an industrial engineer in road transport in a small company based in Durban. Can you see my slide, my screen?
I can. If any of the
Excellent.
audience cannot, please do leave a comment in chat.
Okay, so on your screen is the very first electric heavy-duty truck in South Africa that was sold by Volvo. It was purpose-built as a car carrier. So this is our pride and joy in our fleet, and that explains that first slide. I think it's a massive step forward for electric road freight in South Africa, and um, it's I think throughout Africa, this is now the next major step forward in freight transformation. But just to complete the introduction, whilst the last 15 years or so has been involved, while I've been involved for the last 15 years or so in KDG Logistics in a transport company in Durban, for the last 2 years, I've been working very closely with the Kuna Foundation on a project for the Smart Freight Center in East Africa. And that's focused on the northern and central corridors, developing a support program for the green freight strategies. Um, that's the book that I wrote, Sean mentioned. So this book was written not as a textbook, but as sort of a paint by numbers approach for road transport operators to engage with the problem at hand. And that is how to ensure that we can transform the existing transport operations to a lower emissions profile, whilst at the same time improving profitability. So I think before we get into the meat of the presentation, um, just a shout out to the industry. Road freight gets a bad rap for the emissions, but the reality is that road freight is a key facilitator for trade. Certainly in Africa, where we have road freight moving as much as 80 to 90% of all the freight in many countries, it's absolutely essential for society to function efficiently and effectively. It allows for agricultural and industrial specialization and the movement of goods where it's required. And without road freight, life as we know it ceases. So we have a huge reliance on road freight in Africa, but we have to also bear in mind that there is a negative consequence of road freight in the form of congestion, road wear, air pollution, and road accidents, to name a few. So as road freight professionals, it is important for us to bear in mind that these two have to coexist, and we have an obligation to society to minimize the negative impacts and to maximize the positive impacts of road freight. So I think the evidence is fairly clear by now that global warming is real, climate change is real. We are fast approaching some seriously dangerous thresholds and tipping points in the climate narrative, with the 1.5 degree warming mark being passed, and 2 degrees potentially on the horizon. The imperative for climate conscious industry is without question at this point. But I think it's also important to look at where we are in the timeline. The first paper on the effect of CO2 in the atmosphere on the temperature of the ground was written in 1896 by Svante Arrhenius. So this is not a new crisis. It's just that our response to it has been somewhat slow, somewhat delayed, which will then highlight the need for urgent action. Sometimes when we talk of long timelines for projects and we set targets for 2030, 2040, we lose sight of what that really means. And it's important to look at it in terms of the generational impact. So if you were born in the 80s, then a 2050 target is absolutely relevant to you, because you're probably going to be in your early 70s by 2050. And if you have youngsters in the family that are born in the last 3 or 4 years, 2090 targets even are relevant for them. So I think we tend to be people who are driven by urgency and immediacy, but the climate timeframes should not be something that catch us out. Road freight has a disproportionate share of emissions burdens, and you can see here in this slide that if you compare it to the other forms of freight, certainly it is as much as all the others combined. So road freight needs to take a disproportionate amount of action towards reducing the emissions. Sean mentioned the fact that heavy-duty vehicles make up about 4% of the global fleet of vehicles on the road, yet emit around 36% of total emissions, with 73% of total NOxes. So the opportunity is through actions concentrated on a relatively small number of vehicles to make a massive difference to the CO2 emissions burden of these vehicles or of the total vehicle pool. And the reality is that global emissions from road freight will probably double in the time frames 2015 to 2050. So whatever actions we're planning now, we should actually plan to scale to twice the impact. So I think for me, the real starting point is to contextualize what is the actual impact of road freight emissions, and to make it real. In South Africa, certainly our busiest corridor is Durban to Johannesburg, and I like to calculate the emissions of a single truck in a day to give you a context for what is the actual total fleet in the country doing. So a single truck in long haul on this corridor will use about 300 liters of diesel, which would give you about 972 kilograms of CO2 equivalent produced by one truck in one day. And we have over 350 trucks in the country. So this gives you some kind of scale of impact of the national fleet in terms of CO2 burden. And certainly if you have a transport fleet that's within your locus of control, whether it's 100 trucks, 200, 1,000 trucks, you now have some sort of context of what sort of emissions lies within your locus of control and what sort of emissions you can actually have impact on. So it's very easy to calculate what is your total CO2 burden from your fleet. If you're a transport operator or if you're an LSP, you simply multiply the number of liters consumed by your fleet by 3.24, which gives you the kilograms of CO2 produced. So given that context, it's vital that we learn how to calculate these emissions, how to report them to customers that care, and how to reduce these emissions. And sometimes it's very important also to calculate the impact of these actions on the business, because if we can demonstrate that it is cash flow positive, it's a lot easier to get traction within the business to reduce these emissions and to build action plans to net zero. Very often in transport businesses, there isn't a strong drive for CO2 emissions reduction. The focus largely in transport businesses is simply to move product from A to B and meet the customer demand for immediate and sometimes spectacular service. Very often, climate objectives are relegated to the back seat if they are taken into account at all. So if we can demonstrate that these actions are hugely cash flow positive or profitability positive, then there's a greater chance of us securing interest and action within the business towards CO2 emissions reduction. So some of the work I do certainly in the past year and a half has been focused on working within the East Africa Green Freight Support Program, which is a Kuna Foundation initiative. And in this program, we are working towards bringing various actors together, the freight buyers and the freight service providers, together with the governments, academic institutions, development foundations in the region, to build a collaborative ecosystem around the green freight objective. And it's largely focused on developing the awareness and also building capacity so that skills and knowledge development within the entire stakeholder body both towards decarbonization of existing transport fleets, as well as building pilot projects and trying to develop scale over time of zero emissions projects, freight electrification in particular. The Northern Corridor has recently signed the Global Corridor Initiative. So, we're seeing some movement there in terms of the governmental stakeholders. And for me, it's vital that we support all of these initiatives with an underpinning of knowledge base and skills development so that people are capacitated to move in the right direction. So okay, sorry, wrong direction. In terms of the Smart Freight Center and the way we approach decarbonization initiatives, it's basically a 4-point plan. It's fairly simple. If you can teach people how to calculate and report the emissions, and then set targets that are credible and achievable within the business, help them understand what the reduction activities are that you can deploy within the business, and then how to measure those reductions and report it through what you've learned already in terms of the GLEC framework reporting of the emissions. And then within the business, scale those activities up so that you maximize your environmental benefit, and then collaborate and advocate within your sector. So build the case studies and make your change actions visible so that we can catalyze change across the entire industry. So within the company that I work in, KDG Logistics, I started an engagement with Professor David Sibon at Cambridge University around 2016, and he developed this infographic which shows some of the carbon emissions reduction activities you can deploy within a fleet. And what's interesting is that he looked at what is the barriers to adoption versus the emissions reduction potential. So this could give you an idea of where you could find lower hanging fruit in terms of the intervention strategies that you wanted to deploy. So if you wanted to find interventions that were relatively easy to deploy, you look to the right of the curve. And this is things like simply getting your tire pressures right, getting your vehicle routing right, a bit of driver training, using the telematics to understand your data sets within your fleet, providing drivers with feedback. So these are things that are immediately within the locus of control of a transport operator. And it's a low-hanging fruit in the sense that it doesn't require much capital expenditure to get going. It's relatively easy within the normal business process. But they also provide you with up to about 10% emissions reduction potential. And where that's really important is that it's very difficult to change 10% of your fleet right now to zero emissions vehicle. I would say that if you want to do that within the next 3 months, it's almost impossible to achieve changing 10% of your fleet to zero emissions vehicle, but you could change your entire fleet to reduce its emissions by 10% easily within 3 months. So that is certainly the decarbonization low-hanging fruit in terms of trying to transform the transport business. But if you're looking for more long-term high-impact measures, you look to the left towards freight electrification. And these timelines were put into this infographic around, I think, 2015, 2017. And certainly with the advances in electric trucks in recent times, we are seeing that these timelines could possibly come a lot sooner. Samita mentioned earlier that in many parts of the world, freight electrification comes at a capex cost double of the diesel vehicles replaced. In South Africa, we're seeing that the electric trucks cost more than 3 times the price of diesel trucks. So it's a much higher hurdle that needs to be faced, and there's very little in the way of incentives from government at this point. We're hoping to see some change in that. So the focus largely in the African projects is on building skills towards the dual objective, decarbonization of the fleet as an immediate imperative, but also creating an understanding of how do we motivate fleets towards the CapEx requirements of freight electrification, and how do we start building those early pilot projects and developing traction in the longer term towards zero emissions freight. So it's a dual trajectory, it's parallel strategies. Okay, so from a vehicle decarbonization perspective, it's fairly commonplace now. The understandings are quite clear that there are many fuel-saving technologies that are easily available. There's enhanced aerodynamics, weight reduction, low rolling resistance tires, reducing the accessory loads on the vehicle itself, improved powertrains, idle reduction technology, improved engine technologies, as well as moving to the higher Euro levels, intelligent telematics and driver aids, providing drivers with intelligent feedback on their driving. So these are easily available to any transport operator in many parts of Africa right now. Telematics is still somewhat limited in some countries, but for the most part, all of these are somewhat accessible. So going back to where we started with the decarbonization strategies within KDG Logistics, around 2017, we did low rolling resistance tire studies, and we found that through about 400,000 kilometers of tire testing, we found that there were distinct advantages from a CO2 emissions reduction perspective, but also from a cost perspective in low rolling resistance tires. Together with this, we started developing active tire management strategies where we started doing our wheel alignment in-house to improve the frequency of wheel alignment, as well as regular tire inspection. So every truck gets inspected once a week for tires, tire damage, tire inflation pressures. And these combined actions together probably reduced our emissions in the order of magnitude of about 10%. We looked at what we could buy in terms of the best-in-class assets for our purpose, and the vehicle manufacturer had a basket of technologies available. And interestingly enough, if you take out the low rolling resistant tires, all of the other options together probably combined would give us between 2.5% and 5% reduction in fuel consumption and reduction in emissions. And at this point, we found it was very difficult within the business to motivate this change, because when you talk to the owner of a transport business about reducing fuel by 2.5% or 5%, there's no real interest because it all falls on deaf ears. People do not believe that a 2.5% or 5% change is meaningful in any way. So what I found was it was necessary to try and change the narrative somewhat from talking about these small percentages to trying to figure out what does it actually mean, not just in terms of cost reduction, but in terms of what is the impact on your actual profit. So in developing an action plan within the business, what it's about is trying to figure out, what are the easy to implement actions? What are the most impactful actions? What are the hurdles that stand in my way to implement them? And then what is the cash flow and profit impact? And through this, we figured out how do we motivate the change? Or what is the motivation for change? So if it's a customer imperative that you reduce your emissions, then that's a fabulous driver for change. But in most transport companies, certainly in Africa, that demand from the customer is still fairly light-handed. So what I find is in advocating for the change, it's easier to focus on the profitability on the business in terms of motivating the change. So when climate goals are not immediate and urgent, I think cost reduction sometimes feels a bit soft, but if you focus on the profitability, there could be some answers there. So in the transport business, it's important to figure out how do you calculate your cost components, because this is key to understanding how each of these cost components impacts the business. So it's commonplace in a transport business to break down your costs components into CPK, that's cost per kilometer. But it's less common to understand the interdependence of these cost components on each other, and what happens when you activate certain levers within the transformation space in those discrete cost drivers. And sometimes
Abdul,
cutting
we're going to
costs
move
across the...
to questions in about a minute or so, just to let you know in case you wanted to wrap up with some overarching comments as well.
Okay.
Thanks.
So when you look at the cost drivers in the transport business, if, for example, you have a project that reduces your fuel consumption by 10%, what you find is that because fuel has a 40% impact on your cost, that could actually improve your cost performance by 4%. But in a typical transport business with a profitability of 5%, reducing your cost by 4% actually increase your net profit by 80%. And that for me was the magic. If we focus on the profitability improvement, because of the direct impact on profitability of the cost management, we could actually find stronger motivation forces in that relationship. So largely what we focus on now, instead of cost reduction, is how do we maximize our profit and what is the impact of these change measures on profitability? So when looking at the implementation levers, we need to bear in mind what is the impact in terms of CO2 emissions, what is the impact in terms of cost performance, and how can I use the profitability measure to drive the impetus for change. So typically in a small transport company that uses 200,000 liters of diesel in a month, a savings of 20%, which is easily possible through a combination of these measures, gives you an impact of about 40,000 liters of diesel saved. And in most instances, this is absolutely material in a road transport business. So to inspire the change, one needs to have both the environmental objective in mind, but also a clear understanding that the transport business has profitability very high on the agenda. So the action steps in driving this transformation is encouraging transport operators to develop an implementation plan for change with the baseline, start to measure the impact of the change, monitor the operational performance, and match it to the financial performance. And very often it's vital to report the profit impact within the executive of the business to make sure that the change is not just scalable, but that it can continue in the long term. To create a reporting framework for that, both the CO2 emissions reduction and the profitability, and to celebrate that victory. So all of this needs to be underpinned by developing the knowledge and skills base within the industry to calculate emissions, report emissions, reduce emissions, and to motivate these initiatives so they get implemented across the entire business and across the industry through collaborative efforts. Thank you so much.
Thank you so much, Abdul. That was a brilliant point to end on as well. Often the side of the business that we in the policy space don't actually see as much is the impact on profit. And so I think we're going to now go straight into some of the questions. I think the first that's really jumped out to me from Ankit, I'm going to direct actually at both of our speakers. First, Samita, then Abdul. The question is related to the context, Samita, that you were using in India around the subsidies that are being provided, and that potentially these subsidies at the moment are quite small in comparison to the cost differential between an electric truck and a fossil fuel truck. And so the question relates to whether it is worthwhile to wait until the decline in battery prices and the decline in electric trucks in terms of price brings that cost differential much closer together so that the subsidies have a much larger impact. So is it worth waiting to and using those available funds at a later date when the cost differential is closer and may have a larger impact? And so I think if you could answer potentially from the policy perspective, then we can ask Abdul to answer from the perspective of the truck purchaser. Thanks.
Thanks, Sean. And just for everyone else's context who is not familiar with PME Drive, it is basically one of the recent policies that is announced in India with respect to electric vehicle adoption generally. Some of the earlier national level policies have been FAME 1 and FAME 2, which stands for faster adoption and manufacturing of electric vehicles. And the next policy in place with respect to providing these upfront subsidies is PME Drive. And it is also one of the very first policies which has allocation for zero emission trucks as well. It has allocation of 500 crore rupees. I'll have to do a little bit of math and get back in terms of what that means in terms of different currencies. But all in all, the announcement of having subsidies for electric trucks under PME Drive is definitely a promising step towards broadly decarbonizing freight sector and trucking sector. However, the funding that is allocated is really limited and relatively small, especially considering how high the capital cost of electric trucks is. So I think the question that Ankit has shared is really valid. There are pros and cons on both the sides in terms of kind of arguments for waiting for the subsidies, as Ankit also has mentioned the costs of the vehicles or cost of these zero emission trucks would decrease in the future, especially as the technology, might that be batteries or fuel cell, keeps on getting cheaper and more efficient. The technology will also mature, and hence there could be a multiplier effect. And a delayed subsidy program can probably yield greater economic benefit and more returns. But at the same time, there is also an argument to be made for immediate disbursement, especially considering how nascent and infant the whole market is. The immediate subsidies provided, especially at this nascent stage, could really share a strong demand signal and can support manufacturers in terms of achieving the economies of scale at a faster rate, especially for first moving early adoption cases. And I also spoke about those in my presentation with respect to ports or industries, corridors. The early subsidies can really help fleet operators overcome the upfront cost, and it can really set the ball rolling and create a market for zero emission trucks broadly. It can also support with infrastructure build out, which can be utilized in the future. And considering how India's freight sector broadly disproportionately corresponds to air pollution as well as carbon dioxide emissions, delaying subsidies could really slow down that transition. But that being said, I think rather than having like an all or nothing approach, there could be more of a phased approach where the subsidy can be front loaded to targeted early moving use cases such as e-commerce or ports or um, corridors, and then that quantum can be adjusted over time in the future. In addition to that, considering the overall quantum of the PME drive subsidy is also relatively small, it definitely has to be complemented with different blended finance mechanisms, right, from concessional finance, as well as any other de-risking measures, business models. That was also one of the reasons why I really wanted to speak about the whole system approach of combining policy, finance, along with infrastructure and technology development, rather than only focusing on one piece of the puzzle.
Thanks, Amita. Across to you, Abdul.
Right. So transport for me, sorry, it's a great question, right? But transport for me is two things. One is the actual transport operation. The other is the strategy behind the business. Because you are competing in a marketplace where very often the market dictates your selling price, but it's the way you manage your operations that determines the buying price of every truck kilometer. So, you could ask yourself the same question about any technology. You could wait for the next cell phone, the best cell phone to come out, and you wait indefinitely to buy your first cell phone. But what's really important about accelerating the pilot scales and pilot projects of electric freight is that if you consider the cost curve for a diesel truck versus the cost curve for an electric truck, right now the electric truck, certainly in the use cases I've looked at, work out to around 20 to 22% more per kilometer than a diesel truck. By 2028, I believe these curves would intersect, and post 2028 or thereabouts, electric freight should be cheaper per kilometer in many use cases than diesel freight. Now, what this means from a freight strategy point of view as a freight operator is that if I wait until 2028 to start developing my understanding of this technology, because it's not really a technology transition, it's more an energy transition. The truck is more or less the same. It's just the energy that propels it is different, and there's some maintenance aspects slightly different. But what I need to do is I need to develop the understanding within my business of how to set up the charging, where should it be, how does it affect my route scheduling, what is the actual impact on my business? How do I develop a new way of thinking and operating around this new technology in this timeline until the curves intersect? Because whichever freight company is best positioned to scale post that intersection of curves, that's the company that will have the best strategic cost advantage. So if I wait until 2028, it might take me 2 or 3 years to develop those competencies, and a competitor of mine that already started building those competencies early would have a massive cost strategic advantage in that space. So for me, it's a game of strategy. The early adopters will carry a small price burden. So if you've got a fleet of 200 trucks and you start an implementation of 1, 2, 3 trucks right now, the impact on your total fleet cost is a small order of magnitude. But the potential upside in having that skill base developed within your business and that new business architecture to go to freight electrification or zero emission freight, I think for me, that's a huge positive.
Perfect. Thanks so much for sharing on. Yes, what was a very insightful question. I think we're going to now move across to our third speaker, Mr. Jose Ignacio Huertas. Jose is a professor in the mechanical engineering department at Tecnológico de Monterrey in Mexico. He is with the Energy and Climate Change Research Group and is working on the energy efficiency of HDVs, as well as a number of other related topics. And he's also the leader of the Latin American Research Network on energy and vehicles. And so we really appreciate his time for being here and sharing some of the research that he's been doing, the knowledge that he's gained in this space. So thank you so much, Jose.
Good morning. Please confirm that you can hear me.
But we can hear you, Jose.
Okay. Let me share my presentation then. Now, please confirm that you are looking at my presentation.
We are not seeing the single slide. We're seeing the presenter view with 2 slides.
What about now?
Now we're seeing it perfectly. Thank you so much, Rebecca.
Okay, sorry for that. It is family time now here in Mexico. Well, let me swap this to here. Let me present this work on behalf of all this group. Let me support it. Yeah. All this group and all this institution that you can see over here. The purpose of this work at the end is to reduce the CO2 emissions of the transport sector. And then what we are doing have 2 main objectives. The first one is to establish what we call the baseline of fuel consumption. The idea is we were required to present that information in terms of this metric that you see over here. And then, based on that information, we were asked to propose a methodology for defining an energy efficiency program, which I will explain a little bit later. So, before establishing an energy efficiency program, in this case for Colombia, it's important to understand the operation of how these vehicles are used, not only in Colombia but around the world. The first thing is that the fuel consumption of the vehicles depends mainly on 3 aspects. The first aspect is on what we call the external conditions, which basically is just the infrastructure that the country has for the for the vehicles. And if we want to quantify or qualify how efficient is that infrastructure, we should use the metric of liters per kilometer. The second main influencing factor is the technology, and that is responsibility of the manufacturer. We have to say that in this case, there is not a single manufacturer. In a single vehicle, you can have at least two manufacturers. The one that provide the rolling chassis, which means the engine and the chassis, and the other one which manufacture the body of the vehicle. Then somehow those at least two companies are responsible for the energy performance of the technology. And so far, it has been traditional that the energy efficiency of these technologies is measured in liters per kilometer when the vehicles follow a driving cycle. Then the third aspect is how we use, or how the company that use the vehicles. Then let's say the main influencer in the fuel consumption is in this third region. So, sorry, but if you want to quantify the efficiency of these companies, you have to use this metric, basically liters per kilometer transported and ton transported. Then if you want to design an energy efficiency program, at the end you have to design a program for the government who provide the infrastructure, another one for the manufacturers, and a third one for the transport companies. In this work, we exclude this aspect from the scope of our work. So let's continue with that mental map. Let's continue with these two programs. Before explaining the programs, it's important to say what are the local conditions. Colombia, probably you know, but it's better to say, is characterized by being part of the Andes Mountains. And then the vehicles have to go from the sea level to the cities that are located up to 2,400 meters above the sea level. And then the roads are not mostly straight. They have to curve around the mountains. And then the most used vehicles are these that you see over here. The second one is this type of vehicles. So, and then as you can see here, most of the vehicles transport less than 5 tons payload. The second one less than 10 tons, and very few are for large payloads. And over here you have the distribution of Model Year, as you can see from this, that the Model Year is about, the average age of the vehicles is about 15 years old. And finally, another characteristic for the Colombian heavy-duty vehicles is that they are all imported. Because the rolling chassis, all of them are imported, and they are dominated by few manufacturers, as you can see over here. With that in mind, what is the next step? What we did it next is to monitor the operation of those vehicles and the real condition of Colombia. How we did that? The first thing was to connect to the computer that control the engine of the vehicles. Somehow we connect to that computer, and then we get information at 1 second, at every 1 second, of where the vehicle is, the engine RPM, the vehicle speed, the fuel consumption. And for this work, it's very important the payload, but that information we couldn't get it straight from this system. The good news is that, sorry, this is advancing too fast. The good news is that we were able to monitor many vehicles, and we send information to the cloud, and then finally in our desk we have all that information of the operation of the vehicles. But we had to, how we did that? Well, in a cooperation with companies. Usually large companies have something that is called telemetry system, which is basically what I already explained it. And then we have access to historical data of that information of the vehicles. Important to say that so far we have completed the monitoring of at least 500 vehicles, with for more than 1 year at least each one. So with that information, we could present or continue with the next steps. As I said before, for this work, it's very important to have the the payload. So since that information is not ready, we have to develop a work on how to monitor payload. And basically here, what we are saying is we explore many technologies, and finally we decided to keep this one, which is an ultrasonic sensor. And during test, we found that it exhibits proper performance. So we could track the payload of the vehicles. Then what I'm going to present next are the main results. Here we present the fuel consumption kilometer by kilometer on the main roads of Colombia. The red dots means that for some reason, those places, vehicles exhibit high fuel consumption. We don't want to continue deeply in this information, but we better continue with the energy efficiency programs. Then, as I just explained at the beginning, we have to develop an energy efficiency program for brand new vehicles and for in-use vehicles. The first one addressed to the manufacturers, and the second one for the transport companies. Here are the specifics of the program. In green, I will come back to this one, but basically the strategies to reduce energy consumption is something that we call the labeling program, and use that information to promote these companies to use better technologies, and also the promotion of electric vehicles. And here we have something in common, is that we are advising the creation of something that we call the centralized information system. We will explain this a little bit later. And for the transport companies, the strategies are something that we call carbon credits and self or auto regulation. Out of the scope of this work, but it's directly connected to the objectives of this program, is the maintenance and maintenance program, which were already mentioned in the previous presentation. So let me start with explaining a little bit in detail the energy efficiency program for brand new vehicles. Okay, the first thing that we have to highlight that this is focused to or addressed to the manufacturers, and the metric that we choose to use is the efficiency, or as a second alternative, the liters per kilometer or the grams of CO2 per kilometer when the vehicle is tested and following a local driving cycle. And then to do that, we propose 3 equivalent methods, which means that if we choose to do this, the first, second, or third, we will conduct it to the same result. The first one is simulation. This simulation, well, basically we are recommending is to adopt this tool that were developed in Europe. Basically, you can predict the fuel consumption of new technologies. Since this is a simulation, we are also advising the verification of that simulation through any of these 2 methods. And the second method is to test the vehicle on a chassis dynamometer, which is something that is traditional. However, the main problem of this is that the infrastructure in terms of dynamometers is quite low in Colombia. But there is another alternative, which is to test the vehicle on road. And this can be done in a non-expensive way. Before going to explain the energy efficiency programs, I will come back to that. let me tell you how we develop the metric of energy efficiency. Basically, we start with the telemetry system, where we have the historical data of the position, the speed, engine RPM, and fuel consumption of the vehicles, second by second. Then we compute what is the demand of the energy of the vehicles just to move. Let me say, I don't want to get into details, but basically this is the definition in green here, the definition of energy efficiency. And then we compare the energy needed through this model with the actual energy consumption measured here through telematic systems. And basically, what we do is this a correlation analysis, and the slope of that curve is the energy efficiency. We did that for the many vehicles that I already explained to you. And we have this energy efficiency distribution, and this is discretized by the type of vehicles. So let's say for this vehicle that I'm showing over here, then we know what are the, let's say, the 10% worst performance or the 10% best performance. The 10% best performance, we assign a green label, and the worst 10% is a red label. And this is the basic for the next strategies. And we did the same. Just to mention, light-duty vehicles are in this, most of the light-duty vehicles are in this region, around the 20%. And the electric vehicles are in the 70%. So if we develop programs that promote the use of better technologies, we are already including the electric vehicles. So let me go back to describe the energy efficiency program. I already mentioned this. So basically, the first step is to establish this labeling program that I just explained to you. And then the idea is to establish a strategy, which we call it the promotion of green technologies. And basically the idea is limiting the annual sales of technologies in the way that the average annual efficiency of the technology, the combination of technologies sold is less or higher than a specific value. And also, we recommend to harmonize the existing incentives that the Colombian government has for vehicles in the way that it promotes the electric vehicles. And another recommendation is to create something that make all this information that we have already gathered to make it public. All the labeling should be public. And that's it for the brand new vehicles. Now let me move to the in-use vehicles. In this case, the program is more complicated. But let me start saying that this address is not for manufacturers, it's for the company that transport goods, not only within the city, but inter-cities. And the metric that we choose for them is the emission of CO2 per ton kilometer traveled. And this is per company, not per technology. And how this is calculated, basically following this protocol that is already well established for determining the CO2 emissions of fleet, vehicles fleet. The main problem, let me now in the same fashion go to the results. Let's say we did, since we had the information, then we get the specific fuel consumption, as you can see here, because we promised to do so, and also in liters per ton kilometers. But the problem that we have over here is that it depends on the company. And therefore, we cannot use it to compare technologies. We cannot use it to compare companies because each company is different than the other. This result is just for a matter of comparison. And the same happened with the emissions. So these emissions depend on the operation of the company. So what we what we propose is a voluntary adoption to this program from each company, where each company compare the emissions to their themselves year per year, and they elaborate a voluntary program of reduction. Some people have said that it shouldn't be voluntary, but it's something that is still under discussion. And also, we find out that it's very, very important to find an institution or a body that help these companies to reduce their emissions through the many strategies that were already mentioned in this conversation today: eco-driving, fleet renewal, electric vehicles, and so on. Just to finish, it's something like this. It's something that is made of the community, the government, companies, universities, where we have a lab and people, expert people, and then they advise the government, they advise the companies in how to reduce energy consumption, and they contribute to capacity building in terms of training people on how to reduce energy consumption in these vehicles. That's all. Thank you very much.
Thank you so much, Prof. That is some very rich research that you've been doing in Colombia, and I'm interested whether you think that the factors at play related to the energy efficiency of the vehicles are likely to change significantly in the next few years in both the fossil fuel vehicles as they then transition to electric, or more generally, what research you think needs to be done next to move this energy efficiency program forward for Colombia.
Yeah, the truth is we don't believe that doing nothing is gonna change anything. That the market is not gonna force the transition. That is because many reasons, and mainly because the operational cost, as it is now right now. That energy efficiency program has to be established. So unless the government establish an energy efficiency program for this sector and the other sector, there is not going to be a relevant change in terms of energy efficiency. And the key part is the establishment of this regulation, the promotion and the establishment of a body center that help companies in advising them how to reduce their emissions and their fuel consumption.
Thank you, Prof. We have another question in the chat. I think it's for yourself and also maybe for our other speakers, related to zero emission trucks and the charging infrastructure. At the moment, there are options like catenary systems, hydrogen refueling, but building out large charging networks using that infrastructure will take quite a lot of time. And in those years, fast charging related to the battery chemistries is going to move forward quite significantly. So I'm not sure if you have any views on whether Colombia or other countries should start with catenary or other charging technologies that they have at the moment, or wait for fast charging and the related chemistries to advance before investing in that. So, Prof, if you have any views, otherwise then we'll move to Abdul.
Yes, I have an answer, and it comes from practicality, from the experience. I don't see that the long distance hauling should be converted into electric, and that is not going to happen in the next few years. But there is a lot of improvement that can be done in urban transport, in the urban transport of goods. And the reason for that is that electrification is better for small size vehicles and with low autonomy. When you want these, let's say, big vehicles to be converted into electric, you need to include many batteries. You are duplicating the weight of the vehicle. And then you are transporting nothing. You are transporting a lot of mass for just providing energy. The things becomes different when you use something like hydrogen going through a fuel cell. That makes the difference. But that technology needs to be still become commercial to go to industrial level. There is still a lot to be done in that sense. But since I already said that there are many opportunities in the let's say low autonomy with smaller vehicles, and that is appropriate for urban transport, then I will recommend for the case of Colombia, to focus on that. I don't know what the other speakers think about that.
Thank you. Yeah, I know it's quite dependent on the context. Abdul, would you like to share from your experience?
Yes. So my experience is maybe a little bit different from that, in that in many instances, urban short hauls, light delivery vehicles are currently cost competitive, electric freight versus diesel freight. And I believe that the charging infrastructure capabilities currently in Europe are around the 1 megawatt scale charging. And given that there are at least three truck manufacturers that I know of that are currently trialing 600-kilometer range electric trucks, I believe that by about 2027, 2028, we will start seeing these being deployed and commercially around the world. And what that would mean is that you would be able to complete your entire day's work, which is typically for us around 600 kilometers in long haul, on one charge. Now, this capability means that electric heavy duty long haul freight certainly would be possible. Now, in comparing it to another technology like hydrogen fuel cell trucks, I'm drawn to the simple reality that freight has to be cost competitive. It's very difficult to sell freight to a freight buyer if you are not competitive. They're not buying a carbon emission certificate. So the argument for electrification of freight in the long term as a zero emissions alternative versus hydrogen is backed up by the simple fact that a hydrogen fuel cell truck is essentially an electric truck with a range extender in the fuel cell. And typically, these are going to be around the 20 to 40% more expensive than a battery electric truck if you look at around the 2028, 2030 horizon. But your cost per kilometer, which will largely be driven by the cost of hydrogen, the efficiency difference between the two implies that there's probably going to be about a 3 times cost per kilometer from the cost of fuel. So the hydrogen versus the electric. So I think certainly the argument for long haul freight electrification does exist, and I believe it'll become a dominant argument post 2028, 2030. And also, I think it's very important to understand that all of the freight transformation actions will have to be cost competitive. Sorry, just one last thing. The calculation that I have done to date, if you're trying to develop a cost competitive model, you have to maximize the number of kilometers driven that you can charge for. And typically, you're looking at around the 15,000 to 20,000 kilometers driven per month. So urban short haul heavy duty freight becomes challenging, but long haul heavy duty freight becomes more cost competitive as you approach that 20,000 kilometer per month mark.
Thanks, Abdul. Samita, would you like to give us our last point and then I'll wrap up?
Yeah, I would definitely agree with Abdul over here. I think there is definitely a very big case for long haul heavy duty truck electrification or just converting into zero emission trucks. With respect to final mile and delivery, the market is already there. You can see like a lot of uptake with respect to 2, 3, 4 wheelers getting converted into electric vehicles in large part of geographies. In India right now, like about half of the vehicles, 3 wheelers sold are already electric. and that percentage is growing in rest of the part of the world as well. When it comes to heavy duty electrification, yes, definitely there are lots of challenges with respect to cost right now, but the future is electric. The future is zero emission technologies, as especially as the cost of these technologies starts reducing. And also as countries and as private sector is also getting more and more aware of different net zero targets. That being said, coming to the question directly, I also shared a link of a report that we have worked on. We have compared 8 different technologies: slow charging, fast charging, ultra fast charging, swapping, catenary induction, hydrogen ice. And we have compared these 8 different technologies for Delhi Jaipur, which is about 300-kilometer long highway, which is considered to be one of the early moving Z corridors in India right now. And what we have done is we have identified what the costs mean if we were to deploy vehicles at scale versus if we were to deploy vehicles at a pilot stage. So what does it mean to deploy 100 vehicles versus say 5,000 vehicles? And we have, from all of our cost calculations, yes, catenary and induction has a lot of kind of technology lock-in, and it also requires substantially high amount of investment upfront. So until and unless there are a lot of vehicles moving on a particular route, really getting the return on the investment on per truck basis is going to be really difficult, which is where combination of slow fast charging or swapping comes into the play. And the technologies such as hydrogen come into the play, where payload penalty is important. So because of higher weight of batteries, often for battery electric trucks, the payload reduces because batteries take up a lot of volume and weight. Hydrogen doesn't have that problem. The refueling time is also less. So for longer movements with heavier loads, hydrogen makes a lot more sense. So kind of just to summarize, really looking at the use case, distance, application, the kind of goods, weight, volume are important aspects. But all in all, right now, charging, like fast and ultra fast charging seem to be the way to go in terms of the technology maturity.
Thank you so much. And on that, I think I'll wrap things up. We've had a really exciting, spirited conversation, and I think to thank everyone who's joined us today. I think you can hear that this conversation is very exciting at the moment. There's a lot happening, and the conversation is very much still evolving. So I would strongly recommend that you follow the work of our 3 speakers, of Samhita, Abdul, and Jose, as well as to reach out to us at the UN Environment Program or to GIZ if you have an interest on moving forward with your own work in this space. But there are undoubtedly going to be many more ongoing conversations on this topic into the future. And so I hope you will join us for those as well. Thank you so much, and I hope you have a good day.
Thank you for an awesome event. Cheers.
Thanks a lot.
Bye bye.